Factorizing is turning expressions with added and subtracted terms into expressions with brackets. So here's a quick example. This is similar to one we've done before. 6x plus 12 can be turned into 6 bracket x plus 2 bracket. And we can check this by just going 6 times x is 6x, 6 times 2 is 12, and seeing that it actually works, because when you expand the brackets you should get back to the original expression. So factorizing is putting the brackets in, going this way, and ending up with a multiplication, and expanding is going the other way, where you get rid of the brackets and the multiplication and end up with just added and subtracted terms. To help us with some more difficult questions, we learn some patterns. So here's the first one, a shortcut rule. If you've got something squared minus something squared, we call that the difference of two squares, because there are two things squared, a and b, both squared, and they're subtracted. So if you've got a squared minus b squared, you can immediately rewrite it as a plus b, a minus b. Now, just to show that that actually works, I'm going to expand the right-hand side. So a plus b multiplied by a minus b, if I'm expanding it, I need to multiply a times a, and that gives me a squared. Then I need to multiply a times b, and that gives me minus ab, because this minus here goes with the b. Then I need to multiply b times a and b times minus b, and that will give me plus ab and a minus b squared. Now you notice that there's a minus ab and a plus ab, which means that they add and subtract to make nothing. So the net result is a squared minus b squared. So we can use this rule here, a squared minus b squared equals a plus b in brackets multiplied by a minus b in brackets, to help us factorize. To use the rule, we need to actually have two squared terms, and if you look at this first example, I don't. So what I'm going to do is I'm going to change it so that I do have two squared terms, the second one being subtracted. So the x is already squared, so I'll leave that. But I need 9 to be something squared. Well, I can easily turn that into 3 squared, because 3 times 3 is 9. Now I have x squared minus 3 squared. That means if I look at my rule, a is in the position of x, or x is in the position of a, and 3 is in the position of b. So if I write out my rule, a squared minus b squared equals a plus b, a minus b, all I need to do is replace the a's with x's and the b's with 3's. So x squared minus 3 squared equals x plus 3, x minus 3. And look, just to make sure that we know it's right, let's check it. X times x gives me x squared. X times minus 3 gives me a minus 3x, so I've got an x squared minus 3x. 3 times x gives me a plus 3x, and 3 times minus 3 gives me minus 9. And these two subtract to make nothing, or add and subtract to make nothing, so you can see it's x squared minus 9, which is what we really had in the first place. So x plus 3 bracket x minus 3 in brackets is the factorized version of x squared minus 9. In this next example, it looks a bit messier because we've got numbers and letters in each term. There's a 49g squared and a minus 64y squared. And what we really need is a squared and b squared. We just need something squared minus something squared. The trick around this is to make a bracket with that is actually squared. So if I look at 49, it's actually 7 squared. And 64 is actually 8 squared. So I'm going to rewrite this as 7 squared g squared minus squared y squared. If we go back to our indices laws, because both of these things are squared in the first term, the 7 and the g, I can actually put them in a bracket, 7g squared, and with the 8 and the y, I can put them together in a bracket and square it. And you'll notice that now I've actually got two things squared. I've got 7g that's squared and 8y that's squared. So when I look at my rule up here, that means that where the A and the B are, I need to replace them by 7g and 8g. So A is going to be 7g and B is going to be 8y. Now the rule is that something squared minus something squared or A squared minus B squared becomes A plus B and A minus B. So I'm going to put the A term, which is 7g, plus the B term, which is 8y, and multiply that by 7g minus 8y. So you can see that 7g is where the A is, and 8y is where the B is, and also here, A and B. This is the factorised answer. So this whole complex term here is the factorised version of this original expression. In this next example, we've actually got some brackets that are squared. Now that doesn't really matter though, because we just need two things that are squared. So first of all, I've got something squared to be A, and that's the x plus 8 all in a bracket. So I'm just going to call it the bracket. So the bracket squared can be A. But over here where there's a 9, that's not squared. So we need to change it into x plus 8 squared, or keep that the same, and change 9 into 3 squared. Now I've got an A term, which is the bracket, and a B term, which is the 3. So when I write it out, I need to put A plus B, so I'm going to put x plus 8, because that's A, well that's where, that's A, and then I'm going to put plus B, which is the 3, and A minus B, so I need x plus 8 minus 3. So let's have a look at that again just to be sure. A plus B, A, B, A plus B. A minus B, A minus B. So this is A, this bracket, and this is A, and this is B, and this is B. And there's the plus and the minus. This is giving us the pattern, showing us how to factorise an A squared minus B squared. Now, that's already factorised, but we can clean it up a little bit because the bracket that's inside doesn't need to be there anymore because there's nothing multiplied by this bracket in here. So we can get rid of those brackets and just rewrite it as x plus 8 plus 3, x plus 8 minus 3. And if I look at this first term in the first bracket, or the first set of terms in the first bracket, you've got x plus 8 plus 3. Well, 8 plus 3 is 11. So I can write x plus 11, and in the second bracket, I've got x plus 8 minus 3. That's the same as x plus 5, because 8 minus 3 is 5, and they're like terms, so I can add and subtract them. They're actually both constants, aren't they? So this is the factorised version of this original expression, and it's factorised because between these brackets is a multiplication sign and factors are multiplied. And you notice that it's actually not all that much more complicated than the original one this time because we were able to simplify it. In this example here we've got a problem because the 3x squared can't be easily turned into an a squared. There's an x squared, but what do we do with the 3? Well, if we look at the 27, the same problem there. I can't actually turn that into a b squared easily. But what I can do is I can do what we did in our original algebra, and that is to take out a common factor from both the terms. So let's have a look. 3 actually goes into 3x squared one time, because 3 times 1 is 3, and 3 goes into 27 9 times. So I can take out 3 as a common factor and end up with x squared minus 9. And then, because 9 is 3 squared, I can go 3x squared minus 3 squared. And now I've actually got something that looks like my rule. I've got an a squared minus b squared situation. A squared minus b squared, where a is x and b is 3. So that means I can now treat a as x and b as 3. And using our rule, which is a squared minus b squared equals a plus b multiplied by a minus b, then I can write 3a plus b, or in other words x plus 3, and a minus b, which is x minus 3. So with this question here, I've actually ended up with 3 things being multiplied. The 3 multiplied by the first bracket, which is multiplied by the second bracket. So it's even better factorising than the previous examples because we've got 3 factors here.